The main electrical panel is the heart of every electrical installation. It's where power comes into the building and we distribute that power within the building. For a basic installation, the main panel might be all that's needed to supply the required power within a building. But for more complicated installations, we might need something called a subpanel. In this video, we're going to install a subpanel start to finish in the wall behind me. We'll see how the feeder conductors connect in both panels, the differences between the grounding in the main panel and the subpanel, discuss when you might need a subpanel, and we'll finish with an example of how to wire a circuit out of our subpanel. Let's get started. Hey, my name is Dustin. I'm a licensed master electrician. Welcome to this episode of Smarter Sparky. So when might you need a subpanel? There's actually a couple different reasons you might need one. The most popular of all being that sometimes they're just more economical. Imagine, if you will, this main panel was larger, okay? So we had a lot more circuit capability in here. Imagine we needed to run 30 circuits out of this panel to the other end of a building. Now, if that building is 100 feet long, you've got 30 circuits that need to go 100 feet, right? So rather than doing that, you could run just one feeder that's that 100 feet long, set a subpanel in that part of the building, and now all of your circuits can go to that subpanel and be a lot shorter. So it saves a lot of money in the long run. Yeah, that feeder wire is going to be pretty expensive to get there, but it's probably going to be cheaper than running 30 individual branch circuits. Another reason might be that you're doing a remodel on a building. And sure, maybe you could get your circuits to the main panel, but maybe the route to do so is really difficult. Maybe you have to go up through an attic, down a wall, through a crawl space, through another wall, and then there is your main panel. So rather than having to get a whole bunch of circuits through that maze, maybe you just get one feeder wire through that maze, and then you set a subpanel in your remodel area, and then all of your circuits can just get fed from there. Another reason you might need a subpanel is for an outbuilding. Maybe you've got a detached garage or a detached workshop. Rather than having a separate service for that building, you could actually just run a subpanel off of your house panel. Now, there are going to be a few little differences when you're running a subpanel to a building versus just another subpanel in a house or within a business. I'll talk about those briefly at the end. That way, at least you're aware of what needs to happen. But in this video, we are just going to be demonstrating installing a subpanel within a house or within a business. Laid out in front of me, I've got the bulk of the materials that we're going to need for this installation. Now, this subpanel is a 125 amp rated subpanel, but in this video, we're going to be wiring this as a 60 amp subpanel, just due to some logistics constraints on my side of production here. So in order to do that, we're going to need some wire to feed that 60 amp subpanel. This is 6.3 NM wire, or Romex. 6 gauge and 3 wires actually means it has 4 wires, because that makes sense, right? It's actually got 3 wires for current carrying capabilities and 1 ground. So it's got a black, a red, a white, and then a ground wire in it. So 4 wires total, but they call it 6.3. They don't count the ground wire. Now, for those of you keeping score at home, you might realize, well, wait a minute, 6 gauge NM wire is actually only good for 55 amps, and we're going to be running this on a 60 amp panel, right? There is an exception in the code that allows us to protect that 55 amp rated wire at 60 amps, so long as we pinky swear that we're not going to exceed that 55 amps. I don't want to get into the nuances of the code right now. This is more just a video explaining how a subpanel works, how it's wired, and what the differences between the main panel and the subpanel are. So we'll talk about things like ampacity calculations in the future, as well as temperature limitations. Now, if you did want to run this as, say, a 100 amp subpanel, you would just simply run larger wire to it. But again, just for the sake of demonstration, we're going to be using 6 gauge NM, and we're going to be running this as a 60 amp subpanel. The only difference for a larger subpanel is you're just running a little bit larger wire. Everything else remains the same. We're also going to need some straps to strap our wire. We're going to need a feeder breaker for our main panel. We're also going to need some connectors for our wire, and we're going to need a drill bit in order to drill holes through our studs. So our first step is going to be to actually mount the subpanel into our wall. In this case, I'm going to be mounting it within the stud pocket. You could also be mounting this surface mount on a wall. The only difference between being flush mounted within the wall and surface mounted is you would have to get a different cover for it. So this sub panel I'm actually going to be installing in this stud pocket right back here. But before we can actually mount it, we need to do a little bit of prep work on the panel first. There's actually these little knockouts on the side that we're going to use to run our screws through into the studs. So we're going to have studs on both sides of this panel, and there's going to be screws going into those studs that hold the panel in place. So let's get these knocked out, and then we'll be able to go ahead and mount it within the wall. So we've got 4 of these little nubs that need to pop off, and that'll leave a hole so we can run a screw through the side. So I'm just going to use a needle nose pliers, and these should actually pop out fairly easily. Another little trick is once you get it open, a screwdriver will help you pry it the rest of the way, and then you can grab it quite easily with your pliers and just shear it off by wiggling it back and forth. Now that is ready for a screw into the stud pocket. Let's get the other 4 knocked out. And here we can kind of see a little bit of a view on how this actually works, knocking it out on the inside. I'm gonna kind of be doing this backwards here, so don't laugh at me if I miss. Yeah, that's not gonna work. So we can give it a smack with our needle nose, and then we can get our screwdriver down inside there and lift it up, and that will leave it exposed so we can simply grab it with our needle nose. I'm gonna go ahead and knock out the bottom 2 off camera. And there we go, we've got our screw knockouts ready to go, so we should be able to go ahead and install this in our stud pocket. Now these studs are installed 16 inches on center. What that means is our stud from the center of this stud to the center of this stud is exactly 16 inches. So that means between them, we have approximately 14¼ inches. And if we come over and measure our electrical panel, we're gonna notice the panel is exactly 14¼ inches wide. So these panels are actually made for 16-inch on-center stud pockets. So if you're installing this within a stud pocket, you're gonna need to make sure that those studs are 16 inches on center, or you may have to modify the framing in the area, or you may have to add some boards within that stud pocket. Of course, that's a moot point if you're installing the panel surface mount. Because I've already got a panel installed on this wall, I'm gonna match the heights of those 2 panels. We're gonna pretend that the distance here between these 2 panels is 100 feet. So maybe these panels aren't even in the same part of the building. They could be right next to each other. Maybe we ran out of space in this panel and we need to add another sub panel for that extra space. Either way, matching the heights of the panels is gonna add consistency to the installation. So in order to figure out the height of this panel, I'm gonna go to the floor, and it looks like we are at 71¾ inches. So I am just gonna make a mark over here in my other stud pocket at the same 71¾ And now I've got a reference on how high the panel needs to be. There is another thing we need to consider though. Because this is going inside the wall, we're gonna actually need this sticking out of the sheetrock a little bit. So we don't actually want the face of the panel flush with the studs. We actually want it poking out of the studs just a little bit. As a matter of fact, we're gonna want it sticking out the thickness of our sheetrock. We don't want sheetrock between the panel face and the cover. We want metal to metal on the cover. So when we install this in the stud pocket, we're gonna wanna make sure there is a 1/2 inch overlap here of this panel sticking out of the wall. So here's what I mean by that. If we stick this up here into the wall and I just push it all the way back so that it's flush with the back side of the wall here, we're gonna see, yeah, there's a tiny bit of overlap here off the side, but we're gonna wanna make sure there is about 1/2 inch if we're putting 1/2 inch sheetrock on this wall. If we were putting 5/8 sheetrock on this wall, we would wanna make sure the panel is sticking out 5/8 of an inch. So we're gonna wanna make sure there's a little bit of a gap coming back here. Now there's a couple different ways we can do that. A pretty clever way of doing that would be sticking something on the back side of the wall, temporarily of course, just as a spacer. Then you could just simply push your panel up there and screw it into the studs. and then you can remove that temporary piece of whatever it is on the back side. If you don't have something laying around, we can just simply take a tape measure and mark a 1/2 inch back at each one of these screw holes, and then we can simply line up each screw hole and run a screw into it. Let me show you. So this is the opening of our panel, so I'm just gonna measure back a 1/2 inch right there. And I'm gonna repeat that for all of my screw holes, and I'm just gonna use that as my reference mark when I screw it into the studs. And again, these are just gonna be reference marks so we know how far out this panel should be sticking from the wall. To mount the panel, I'm just gonna be using these 1¼ inch lath screws. Pretty much any type of screw would work, whether it be a sheet metal screw, a drywall screw. Again, pretty much any kind of screw that's gonna go into the wood is gonna be just fine. So while it might seem like this is gonna be kind of a difficult operation here, especially with those lines that we made, it's actually really not gonna be that big of a deal. Basically, all we have to do is line up the top of our panel there with our mark that we made, and then we can simply push the panel back roughly, and we're only gonna worry about one screw spot at a time. That's why we only made those marks right next to the screw hole. It's because that's the reference point that actually matters. So we're gonna be able to put one in place, and we're still gonna be able to swing the bottom of the panel enough that we're gonna be able to adjust everything properly. Furthermore, there is enough wiggle in this slot that we're gonna be able to do some fine adjustments after the screw is already started. So that's the nice thing about this. We don't have to get it perfect to start with, we just have to get it rough to begin with. So the first one is always the hardest. I'm just gonna put it up there roughly, right about there is close. Another clever trick I've seen for doing this is using those squeeze clamps, and you can just clamp the panel to the stud, and then you can adjust everything as you wish from there. So I'm gonna put this screw right in the center of that slot. Now I've got the ability to push the panel back and forth a little bit and fine tune it. And hopefully you guys can see there on camera, we can just barely see that mark I made there. And now we can swing this panel however we need to, and we can get the rest of these set up. Just for the sake of thoroughness, I'm gonna throw a level on there. When leveling electrical panels, you have to be real careful because sometimes the manufacturer doesn't quite get the panels exactly square. So the sides might be parallel, but we might actually be a parallelogram here, which means the top and the bottom might be skewed slightly. So you do have to take panels with a grain of salt when it comes to leveling them. In this case, that looks pretty level. We could even double check the side to see if there is a parallelogram error, and that's pretty well vertical right there. It does look like the panel might be slightly skewed. It's not gonna be a big deal, however. And here's what that process would look like from the inside. I've already got the outside lined up. I am gonna put that screw right in the middle. That way that slot can go either way, and I can do some fine adjusting if I need to. And you're gonna wanna leave your panel a little loose to begin with so we can do that fine tuning right at the end. And now we'll adjust this side here. Again, it's just simply a visualization of that mark. And again, we put that screw right in the middle of that slot. And again, leaving it just a little bit loose so we can do those final adjustments. And the last screw, very much the same. I know we've got 3 screws in this panel already, but look at how much we can still move this, because again, we've left everything loose so we can fine tune that last screw as well. And now with that last one, again, we leave it just a little bit loose. Now we can actually fine tune this panel and finally tighten it down. You might need to hold the panel so the screw doesn't want to pull the panel back. We can do the same on this side. I'm gonna get my head in there and double check. And we'll finalize the top as well. And there we go, our panel is mounted. Now we can run the wire. The wire going between our main panel and our sub panel is called a feeder. So our feeder in this case is gonna be this 6.3 NM wire, which again is actually only good for 55 amps, but we're gonna be putting it on a 60 amp breaker, which is actually perfectly legal. The reason is 55 amp breakers aren't considered a standard breaker. So the code says when you have non-standard ampacity wire, you could actually protect it at the next standard size breaker. Again, so long as you promise that you're not actually gonna put 60 amps on this. There are no safeguards safeguards though in place that are going to ensure you never put 60 amps on this. And to be quite realistically honest, putting 60 amps on this probably isn't going to be a big deal. Again, the code says though, you can only put 55 amps on this. In order to run our feeder wire from our main panel to our sub panel, we're going to need to drill holes in our studs. In this case, I'm going to use a 7/8 inch auger bit, and I've actually already drilled holes in these studs in my previous videos. Go back and check those out if you want to see how those holes were drilled. So I'm just going to reuse the existing holes that I already have there. Otherwise, we would just use a drill and drill our holes through the studs. Again, making sure we stay within the center of the stud. The edge of our hole can't be any closer than 1.25 inches from the front of the stud or the back of the stud. So as we can see here, there are already holes drilled through these studs. So I'm gonna go ahead and run the feeder wire straight through our studs here. And I'm gonna leave just enough to kind of start looping around at the top. Ultimately, we're gonna be landing directly up top here, so our wires just need to be long enough to get to there. So here maybe we've got possibly 5 to 6 inches of extra, which again, it's always good to have a little extra. It's cheap insurance. I'd rather waste 6 inches of the wire than find out I cut the wire too short. And now in this case, you know, maybe I've wasted 10 feet. But in the real world, you might have just wasted a 100-foot run of that wire. So that extra 12 inches that you leave in the panel, it's cheap insurance. Don't cut your wire too short. With this thicker wire, I like to actually start working it right away from the back towards the destination. So I'm not even gonna cut anything off of that end of the spool right now. What I'm actually gonna do is we're gonna strip this out and get it into this panel first, and then start stapling it all the way back. In this case, we're really only gonna need one staple down here. The studs actually act as the support horizontally in this case. This cable that we're using is small enough to actually fit in a 3/4 inch Romex connector. If you were using a larger conductor such as 3-gauge SER, if you were running a 100 amp sub panel, you might have to knock out some of these knockouts here in the middle. These are gonna be a little bit bigger. But in this case, because this will fit in a 3/4 inch knockout, I'm actually gonna knock out this far back corner right here and install the wire right there so it can come up the side of the panel and stay out of our way. So I'm just gonna use this needle nose plier and I'm gonna smack the bottom of this knockout right here, and that's gonna flip it up. Here's kind of a shot of that. I know it's not the best shot, but the camera's a little tricky to get in there. So that's all we're doing is we're just smacking the center of that knockout, and that actually pushes it up inside the panel. And this is what we're left with after that happens. So we can just grab that little coin and we can wiggle it back and forth and it'll shear off. But that actually only knocked out the 1/2 inch portion of that. Now we've got this concentric piece that we need to knock out as well. In this case, there's a few tools that we could do with this. The problem is it's actually connected at this point and this point. So it's actually connected at 2 different points. So I like a lineman's in this case. I can come in the bottom here and grab that single side and wiggle it back and forth, and it will eventually shear off. There it goes. And then it's just a matter of grabbing it and pulling it back. You could probably just do this by hand. I'm just gonna grab this with the lineman's and pull it backwards and wiggle this connection point right here a few times, and it will eventually shear off as well. The reason I'm doing it this way is I have found in the past that some of these panels are not punched very well, and if you just grab a corner like over here, or you grab it with just a needle nose, it'll actually break off right before that connection point. So then basically it'll break off just under half of that knockout ring, and then it kind of puts you in a situation where you've got to grab those connection points a little bit more firm and break them off separately. So I've just found it better right away to grab the whole joint with either a lineman's pliers or something like a channel locks or a Nipex and get in there and grab that entire joint and break the joint itself rather than relying on the actual metal of the knockout to actually break the joint. That's probably one of those things that make no sense unless you've been there and had to deal with that. And now we can take our cable connector and install it in the knockout that we just made. So we can take our lock nut off and poke it up from the inside. Again, I am orientating it this direction so the screws are facing out so we're able to tighten those screws down. And they make special wrenches to tighten these lock nuts down. I've never found the need for them. What I'll end up doing is rotating the bottom piece 90 degrees and then grab it with the needle nose at the bottom and twist it that last 90 degrees, and that tightens everything up. And now we can take our feeder wire and feed it up through that connector. Like so. And before I even tighten anything down up top here, we're gonna go ahead and put a wood staple in. I'm not a big fan of these all metal ones. This is all my local hardware store had at the time. I prefer the ones that have a plastic shroud on them at least, but these are gonna work just fine. We can see right here that they are approved for 6.2 and 6.3 NM. And again, if you were running larger wire for a larger sub panel, you would need larger staples that are actually rated for the wire that you're stapling. Back in the video I did on installing a receptacle, if you haven't seen that, make sure you go check that out. We talked about how we actually need to staple within 8 inches of these boxes. And the reason for that is these boxes don't have an internal clamp. So when there is no internal clamp, we have to staple within 8 inches. Because we've installed a clamp on this panel, we can actually staple this NM within 12 inches of the electrical panel. So our staple needs to be between here and here. I'm just gonna grab it arbitrarily right here and we're gonna staple it right there. So I'm gonna hold the wire roughly in the middle of the stud and we can tack it in. Because this is thicker wire, we're not gonna be able to have that nice 90-degree curve right here. We are gonna have to have some of that curvature left. We definitely don't wanna kink the wire so that it actually breaks. So with our wire stapled and it entering the panel, we can go ahead and actually tighten down the screws on our connector. And we don't have to mash these down super tight. They just need to be snug enough that that wire is not gonna wanna back out. There we go. That wire is securely connected now to that connector. Now we can strip out the cable. I'm gonna use a razor blade knife to score the jacket on the sheath. If you do use the razor blade method, make sure you only score very lightly the outside insulation. We do not want to cut through into the inside conductors. They do make special cable sheath strippers, but if you're installing a 100 amp sub panel, you're gonna be using larger cable, and I don't know if I've necessarily ever seen a special stripper for those. So in this case, I'm just gonna score the outside sheath with a razor blade, and we're gonna pull that jacket off. So stripping out this larger NM or even SER wire can be a little bit of a pain in the butt. What I like to do is just score the outside sheath just enough that when I get to the end, I can just rip it off from the front to the back. It doesn't really work on this larger stuff to strip it out at the end and just pull the sheath off. Sometimes you can make that work, but there's just gonna be so much friction on this larger distance here. I'm just gonna start roughly right here, and I am not putting much force on this at all. I do not want to cut through into those wires that are underneath of the sheath. Again, I am barely scratching the surface here. And then at the end, I'll push just a tiny bit harder. And now look at this. Now I can just peel that sheath all the way back and it's gonna follow my score mark. So again, I did not cut all the way through this outer sheath. I just scored it. And now we can pull it back to where I started. And actually it's going past where I started now. That's great because we need it all the way back here. Now it's just tearing on its own. And there I actually was able to just rip it off right at the base there. To be fair, I did kind of score around the bottom there just very slightly in a different take of this, and I forgot to mention it for this take. That actually worked out pretty well. Again, I want to emphasize I did not push my blade hard enough to even cut into the insulation inside of the sheath. I only cut deep enough just to leave kind of a scratch on the surface. And you saw when I started peeling that apart at the beginning, it started to split on that line that I made all the way to the bottom there. Now we can go ahead and land these wires. So in order to land these wires, we have to know where they land, right? So I'm gonna pull this out of the way so our view is more visible. And let's take a look on what's going on in here. Now, if you saw the last video I uploaded, it was a tour of a main electrical panel. We saw all the major components. We saw where the neutral landed in the main panel. We saw where the two hots landed in the main panel and how the main circuit breaker was incorporated in that. And we also saw where our ground system was incorporated as well. Things are gonna be a tiny bit different here in a sub panel. Now this panel is what's called a main lug panel. Main lug meaning instead of a circuit breaker here, there's these two lugs right here that we actually just install our wire directly onto them. And as you can see, if we connect a wire to this lug, it's gonna energize this bus bar. And if we land a wire on this bus bar, it's going to energize, well, this bus bar, right? So our line 1 is going to land over here and our line 2 is going to land over here. Our neutral is going to land on this terminal right here, which if we follow that bus bar straight across, it actually connects to this bus bar and this bus bar. So we've actually got two spots that we can land our neutrals in this panel. One on the left side, one on the right side. That just makes it easier so we don't have to have wires coming across if we've got a circuit over here. That's actually a pretty nice little feature of panels like this. Now, in that last video we saw in the main electrical panel, we could land our grounds and our neutrals on the neutral bar. We absolutely cannot do that in a sub panel. In a sub panel, grounds and neutrals have to be completely separate. So we need to install a ground lug kit. This panel actually came with this kit, and if we look in there, there's actually two ground bars in there, which is actually kind of cool that they send you two. I'm assuming they send you one for over here and one for over here. So these two ground bars are actually going to be installed directly into the panel. And if we zoom in here, we can actually see that there are two ground symbols right on the panel. Now, there's actually 4 different places we could install these ground bars. Notice this little nub right here. We could use that little nub, and there's another nub right here. So that would put a nub on the top and a nub on the bottom. And then right in the middle, we could run a screw. So if we wanted, we could install our ground bar right here and only need to put one screw in the middle, and then those nubs will prevent the bar from rotating side to side. Or right next to it, there is another set of holes that we can actually line up the top, and then we can line up the bottom, and we can install 2 screws. I'm actually gonna opt for the 2 screw system. You could go for the 1 screw system as well. In my opinion, having 2 screws sounds like a lot better of an idea. Notice this ground lug is only rated from 6 gauge through 2/0 gauge. So that means that this 10 gauge ground wire, which is big enough for 60 amps, will not actually fit in this lug. So we're actually gonna have to land this ground wire inside of one of these holes in the side of the ground bar. So I'm going to install the ground bar with the terminal lug on it on this side of the panel. Then I'm going to install this other bar on the left side of the panel. So I'm going to grab this bus bar here with the lug on it and screw in the top screw. These screws are a very tight fit. So that took quite a bit of torque and it's still loose. So we'll go through and we'll tighten everything up once we get this bottom one put in as well. That bottom one is tight. And that top one is tight. And man, is that loud. And we'll do the same on the left side. And now we've got a spot to land all 4 of our wires here. We've got our neutral that's gonna land on this lug right here. We've got 2 hots, and these hots are gonna land directly on the lugs for the bus bar. And we've got a ground wire here that's gonna land over here on this ground lug. Hey, Dustin from the future here. I just wanna clarify something here. Remember earlier we saw that that lug was rated from 6 gauge through 2/0 gauge? Well, I've actually got a 10 gauge ground wire in my 6-3 cable here. So that 10 gauge ground wire actually cannot come up and over and land in that lug. That lug is actually too big for that wire. So instead what we're gonna do is we're actually just gonna come out of this cable here, and and I'm gonna land it right here on this closest ground bar. There is absolutely no reason that we couldn't come around like this and land on this ground bar over here. That would be totally acceptable because both of these ground bars are actually electrically connected together because they both screw into the case of the panel. So they're actually connected together. So it doesn't matter if we tie to the left bus bar or the right bus bar for the ground. The only real issue here is we can't use that lug because that lug is too big for my case here. Now, if you were actually running this as a 100 amp sub panel, chances are you would be using 4-gauge aluminum SER wire, which would come with a 6-gauge ground wire. Well, that 6-gauge ground wire is going to be too big for these little screw terminals here. So if you were running a 100 amp sub panel, your ground wire would have to come up and tie into that lug. And you absolutely could have installed this bus bar over here upside down, so that lug was right here. Then you could simply take your ground wire and install it directly into that lug. That would have been totally acceptable as well. That's the thing with these ground bars, is they're really not fussy. Install them where they fit, where they're approved to fit, and land the wire in whatever lug they are rated for. We have to leave the neutral and the ground separate in this panel. That actually brings me to my next point. This panel came with a box bonding screw, and that's the ground screw that I was talking about in the last video that bonds the neutral to the case of the panel. Because we're installing this panel as a sub panel, we do not want to install this green bonding screw. That would actually get installed right here, and it would tie the neutral bar to the actual case of the electrical panel. Because this is a sub panel, we do not want that extra bonding. That's called a main bonding jumper, and you can only have one of those on an electrical installation, and that's always at the main electrical panel. The only time you would use this screw is if we were installing this panel as a main electrical panel. Because this is a sub panel, this screw does not get used. So because that lug and that other ground bar is too big for this 10-gauge ground wire, I'm just going to install it in this top hole in this left side ground bar. I've got it aiming right for that hole, so I'm just going to hold my thumb kind of on the other side of the bar here to give me where I need to cut, and make a cut right there. And then we can pop it under that screw, fold it into place so it looks nice, and then we can go ahead and tighten that screw down. Here's a little better view of how these lugs up top here work. Our neutral, again, is going to go to this lug. This is going to be line 1, and this is going to be line 2. So this will be our black wire. This will be our red wire. So I'm just going to fold these wires kind of up into the corner of the panel and bend them roughly into shape so they start coming down the center here. And I'm actually going to keep them wrapped up until about the top, and then that's where I'm going to split them off. So it looks like our neutral will be approximately that long. So I'm going to cut it right here and strip it out. Now my strippers only goes up to 10-gauge wire, and this is 6-gauge wire. So I'm actually going to score it very lightly with the wire cutting portion of the strippers, and that will allow me to then remove the insulation like so. And then we can install the neutral. And then we can go ahead and tighten that neutral down. And then the black wire, we can give it a slight little bend right here so it lines right up with the lug. I'll mark the end of where I want it cut with my thumb, cut it to length, and then again, we can just strip it out with the wire cutting portion on the wire strippers. And then we can install it under its appropriate lug. This is where having multiple size screwdrivers comes in handy. This is a 5/16 screwdriver, and it fits these particular lugs just a little bit nicer. And then finally, our red wire, again, we'll give it a slight bend over here so it lines up with the appropriate lug. Mark it with the end of my finger where it needs to be cut. Trim it to length, strip it out. Again, I am not cutting hard enough that I'm really nicking the wires at all. And then we can go ahead and put it under the last remaining lug. Tighten it down, and there we go. Now you might notice that the wires are springing out in some cases, and that can be a real pain in the butt. So what you can do is you can actually bend the wires a little bit, and that will make it have kind of a memory more towards the back. I have seen some situations in which people will put those sticky back zip tie holders in the back of the panel. I've had a few inspectors get upset about that because they're not approved for inside of a panel. Other inspectors don't seem to care. Another option would be using one of these existing holes in the panel and getting those zip ties that have a hole in them so you can put a screw through that and you could pull those wires back as well. But in this case, I'm just gonna give this wire a little bit of persuasion to go more towards the back. We don't have to get it all the way back perfectly, just so long as it's not sticking towards the front. And really, if we just put a bend right down here, that's gonna be more than enough to keep that wire towards the back of the panel. As we bring branch circuits in here, they're gonna lay on top of that anyway, but I would say that's pretty good now. That wire is wanting to stay towards the back. Again, all we have to do is just put a little bit of a bend right down here, and that will help push everything back. And that's all there is to landing the feeder on the sub panel side. Again, our ground goes directly to the ground bar, and it has to stay directly on the ground bar. And our neutral is completely separate, and we do not install that green bonding screw. Our line 1 comes directly to this lug, and our line 2 comes directly to this lug. I want to talk about 2 more technicalities real quick inside of really any electrical panel. First, I want to address this concept of main lug. Notice there is no main breaker here. You can actually go out and buy a kit to install a main breaker here. Really, all you do is you just undo these 2 nuts right here, and then there's a clip right up underneath. The breaker just snaps in, you put these 2 nuts back on, and now you've got a main breaker panel. So all this is just bypassing the need for that main circuit breaker. Our circuit protection for this sub panel is going to be at the main electrical panel. We'll have a 60 amp circuit breaker over there that will protect this wire and the entirety of this electrical panel. So if this were a main breaker panel, could we still set it up as a sub panel? Absolutely, and there would be a couple ways we could do that. The first way is you could just go out and convert it to a main lug panel, and that would be just fine. You would get rid of that main breaker, put lugs here, and pass through. That is acceptable. Another way to do it is you could just land these wires right on the, let's say, 100 amp main breaker. So if this panel did have a 100 amp main breaker in it, you could land these wires right on that main breaker and feed the panel that way. That 100 amp breaker is going to do nothing more than act as a switch, because we're still going to have to protect this wire at 60 amps back at the main panel. So that 60 amp breaker in the main panel would trip before this 100 amp hypothetical breaker ever tripped. So yeah, if you did have a main breaker panel, you could still make it a sub panel. Just make sure you don't have that green bonding screw in there. And yeah, you could just run it on the lugs of your 100 amp main breaker. Another option would be to install a breaker in the panel like this, and you can actually backfeed it. This isn't the right style breaker for this panel. This is actually going to be the breaker we're going to use in the main panel. But if we had a 60 amp 2-pole breaker for this panel, we could install it right here and backfeed through this breaker, and this would be our, well, basically main breaker for this panel. And that's fine. You're actually allowed to backfeed breakers like that per code. So there's actually 3 ways we can feed a sub panel. Main lug, you could pass through a main circuit breaker, or you could backfeed a branch circuit breaker to energize those bus bars. Typically, main lug is going to be the cheaper overall solution. One more boring topic we need to talk about real quick is lug capacity. If we take a look at these lugs right here, notice how small these wires look inside that opening. These lugs all have a minimum wire size. As a matter of fact, 6 gauge is the minimum wire size for these lugs. How do we know that? Well, this sticker right here actually tells us the lug rating of every lug inside this panel, except for the ground lug. The ground lug kit actually comes with its own sticker that says what the rating of that lug is for. So I've done my best to zoom you in here on this sticker, and maybe I can rotate this in editing. Notice here it says lug type, line and neutral lug is 6 gauge to 1 gauge copper, or 12 gauge to 2/0 gauge aluminum. aluminum. That's actually a really weird wire range. The second one here though says main lug. So these would be the two lines. So line neutral lug, that's going to be that big lug for the neutral. Then the main lug is actually 6 gauge to 1 gauge copper or 6 gauge to 2/0 gauge aluminum. So those would be the two main lugs that we landed that black and red wire on. And then if we take a look at this sticker that came with the ground terminals, we will see that the box terminal is 6 gauge to 2/0 gauge. The sub panel's finished for now. Let's head over to the main panel and get that wired. Anytime we're working in an electrical panel, we want to make sure we shut off the main power to that panel. After you're done watching this video, go check out my video explaining what's inside of a main electrical panel. Just because we shut off that main circuit breaker doesn't mean everything in this panel is dead. We would still have these energized lugs in here. The only thing this breaker shuts off is these bus bars. So now we're going to get our feeder up into this electrical panel. Because my main electrical panel is used, I've already got some knockouts that are out of this, so I'm just gonna reuse one of these knockouts that are already here. This is a 3/4 inch knockout, which is exactly what we need for our 3/4 inch cable connector. So just like with the sub panel, we take that lock nut off and we can install this connector like so. I'm also gonna do that trick where I turn it sideways 90 degrees and then use the pliers to bring it the other 90 degrees, and that will tighten it up. Notice how this whole concentric knockout area started to move. We got to be careful we don't wrench on this so hard we break that connection there. If you do break that out, and let's say you break this out to a 1.5 inch hole, they do make reducing bushings that you can use. They're basically big washers that you can use to re-bridge that gap. So we'll estimate how much wire we need. I am going to be landing all of my stuff on this side of the panel. So really I just need wire long enough to get to the top of the panel in my case right here. Again, it's better to have more than enough, so it's better to always just loop up and over. Yes, you waste a foot of wire, but that might save you from wasting that full 100-foot run that you just ran. So I'm gonna cut my wire approximately right here. That way I've got a little bit of room. Basically our grounds and neutrals are gonna land right here, and our two hots, I'm gonna install the circuit breaker in this area right here. Now cutting this larger wire can actually get a little tricky. In this case, I'm just gonna use a pair of diagonal cutters. Ideally, you'd have a larger cable cutter. My cable cutter is not available at the moment, so I'm gonna use what I have. I've got a diagonal cutters. So basically, I'm just gonna come in here and I'm gonna cut each wire individually. And like I said, this is very tricky because these wires are so much bigger, and it's even trickier to hold it up to the camera. Whew. And now we can feed that up through the connector and into the panel. Same thing that we did with the sub panel. I'm gonna go ahead and staple this right now. So we have to staple within 12 inches of it leaving the panel because we do have a clamp there. And we need to make sure the wire is no closer than 1.25 inches from the front or the back side of the stud. Again, in my situation here, we're pretending this concrete wall is not here. So maybe this is the center of a house or something that both sides are accessible. If we were taking this in the literal sense where there is a concrete wall behind there, then the back side doesn't matter. You could staple this as close to the back side as you want with that concrete there. It's just 1.25 inches from any face that sheetrock screws are gonna get ran into. The idea is if a sheetrock screw gets put in crooked, we don't want it going into our wire. That's why there's an 1.25 inch clearance rule. So within 12 inches of the panel, we install one of our staples. And again, we do have to have this curvature here, otherwise we would kink the wire, break the insulation. We don't want to deal with that. If this were a longer run, maybe up inside of an attic going to a sub panel in another part of the building, we would have to support this wire every 4.5 feet. Now, because we're going through studs, it's actually inherently supported every 16 inches as it goes through each stud. So we don't actually have to staple anything as it goes horizontally, but if these were up in rafters or going through floor joists or whatever, parallel to floor joists, we would actually have to staple this every 4.5 feet along that route. So it's within 12 inches of the panel and then every 4.5 feet thereafter. I'm gonna go ahead and tighten the clamp on the bottom here. I'm just gonna use a drill this time. Again, it doesn't need to be super tight. It just needs to be snug enough that that wire is not gonna wanna come out of that connector. And just like with the sub panel, I'm gonna score the outside of the sheath and then I'm gonna peel it back like a banana. This time I did not score the bottom there, so you guys will be able to see what that's like. Again, I am barely scoring the outside jacket here. And be very careful as you're cutting towards yourself here, because this could slip very easily and get your fingers. And then right at the end, right at the very end, I press just a little bit harder just so it actually splits the insulation. Now we can grab that split and peel it back, and watch, it's gonna follow that score mark all the way back. See? Pretty slick, huh? Now again, at the base here, I did not pre-score it like I did over there. So I am going to score it this time just around the base. Again, all I'm doing is just going very lightly, just so you can barely see a scratch. That little scratch is gonna be just enough that when we pull on it, it's gonna break off. And now we can go ahead and land the wires in the main panel. So I'm gonna separate everything here. This ground wire comes with this paper sheath on it, just like all NM does, and we'll peel that back. If you've got SER, it's gonna have more of a plastic wrapping inside of there. Here's where things get a little different. Because this is the main electrical panel, we can actually land our ground and our neutrals on the neutral bar. Go check out the video I made explaining the insides of a main electrical panel, and I explain a tiny bit more detail why we actually share those in the main panel. Basically, in the main panel, the neutral and the ground bar can be shared, but in a sub panel, they have to be completely separate. So I'm gonna separate out the ground and the neutral. We'll put our hots down here on the bottom, just out of our way for now. And I'm just gonna manipulate that neutral and ground into the corner here and get it to bend up roughly in line with the neutral bar here. This 6-gauge wire is actually gonna have to land under this larger screw here. It actually leaves a larger opening inside the bus bar. The 10-gauge ground can actually land underneath of one of these smaller screws. If you are running a larger sub panel, you might need to get one of these add-on lugs that will bolt onto your bus bar so you can land a larger wire on it. So I'm gonna start by landing the neutral wire, and just like before, we're just gonna kind of hold it roughly in place about where it needs to be cut. We can cut it to length and strip it out. And again, I'm just using the wire cutting portion. I'm putting very little force on it, just enough that I know I can cut through the insulation, and then I can peel it off like so. And then we can install it on the bus bar. And then I am just going to install the ground in this screw right underneath it. Looks like it'll be about right here. Cut it to length and tighten it down as well. Awesome, so our neutral and our ground are landed, but what about our hot conductors? Where do we land those? For those, we need to install a circuit breaker in the panel. So in this case, because we're installing a 60 amp sub panel, we are gonna be installing a 60 amp breaker in the main panel. This breaker simply snaps in and then snaps into the bus bar. Again, check out that main panel video for a little bit more detail on that step. Now we can unwrap our hot conductors here. I'm gonna tuck those in the corner the best we can. Again, these are starting to become a little bit larger wires here, so they're a little bit more unwieldy. They're a little bit more difficult to get to where you want them. The correct way to do this is black on top, red on bottom. And that's exactly what we're gonna do in this case. If you're doing this professionally, you wanna stick with phasing colors. Because line 1 comes in on the black wire here, it feeds this bus bar, which feeds every other breaker. That means this top row is gonna be the black conductor. This second row is the red, then black, red, black, red, black, red, etc. So if we wanna do it correctly, we wanna make sure black is on top and red is on the bottom. Would it work if we flipped them around and we had red on top and black on the bottom? Yes, but your phasing is gonna be a little bit different on your other panel. But for a single phase system, that really doesn't matter. When you start getting into 3-phase systems, you really wanna make sure your phasing is consistent throughout the building. That way all your motors spin the correct direction. So we bend our wires roughly to where we want them, and they are ultimately going to land on these 2 lugs coming out of the breaker. So we want our black on the top, so we'll go ahead, give that a cut, and just like before, we're just gonna score it with the wire cutting portion of the stripper. And these breakers, they tend to need to be stripped a little shorter than everything else we've done. So there I've maybe stripped out just shy of 1/2 inch. And we should be able to push that in like so. Notice how we can see just a little bit of copper on the outside of the metal part of the breaker, but we don't see any copper leaving the back side of the breaker here. So we can go ahead and tighten that lug down. And that one is good. And now we can install our second line here. Same thing, we strip that out. A little bit shorter than everything else we've been doing. Open up our lugs and install like so. Same thing, we should see just the faintest amount of copper on the outside. We do not want any insulation under that lug. If we ever got any of that insulation under that lug, that would create an impedance, which would cause heat, which is why conductors melt sometimes. But we don't want so much copper out that we see bare copper outside the back of the breaker here. So let's go ahead and tighten this lug down. And there we go, the sub panel is wired. We are ready to fire this thing up. Before we do, I'll put the dead front on the main electrical panel. And we can go ahead and restore power. I'm gonna leave the cover off the sub panel for right now so we can do some voltage measurements. So let's go ahead and fire up the sub panel. Working inside of a live electrical panel is not something that an unqualified person should do. What do I mean by qualified? It doesn't necessarily mean you have an electrical license. It means you have the training to understand what's actually electrically going on in here, and it means you have the safety training to understand the implications of everything going on in here. If you were to drop something metallic across these bus bars, that could create an arc flash or an arc blast, which can cause severe injury or even death. So if you are not qualified to be in a live electrical panel, you should not be in a live electrical panel. In this case, this panel is live, so I can demonstrate some voltage measurements. Furthermore, I'm gonna be pointing at things in this panel, and man, that looks like my finger is dangerously close to that bus bar, right? I'm a good 6 inches away from that bus bar. Because of the perspective of the camera and the lack of depth of field, it looks like my finger is quite close, but I assure you my finger is that far away from those bus bars. So I am nowhere near touching anything live in here. It may look that way on camera. So let's take some voltage measurements real quick. If we measure from line to line, we get 240 volts, just like we would have in our main electrical panel. If we measure from our line to neutral, we get 120 volts. So just like in the main electrical panel, if we wanted a 120 volt load, we would feed it from one breaker and the other end would go to neutral because this whole bus bar is 120 volts to ground or neutral. Same on the other side, if we measure from this bus bar to the neutral bar, we get 120 volts. It'd be the same if we came over here to this neutral bar as well, because again, that neutral bar is connected all the way up and over. It's also the same voltage if we measure to ground. So from line to ground, we get 120 volts, because remember, at the main electrical panel, neutral and ground are tied together. But in the sub panel, grounds are separate and neutrals are separate. Of course, if we had a 2-pole breaker connected to both of these bus bars, again, that's where we could get 240 volts. So we could put a 2-pole breaker in this sub panel and feed a 240 volt load, such as a dryer, a range, a welder receptacle, or an RV plug. So let's shut this panel off and wire a receptacle circuit out of the panel and see how everything actually lands within the panel. And let's just verify this panel is dead. Phase to phase, 0 volts. Phase to neutral, 0 volts. Other phase to neutral, 0 volts. This panel is dead. Real quick, I'm going to install a receptacle out of this sub panel just so we can see how the wires inside land. If you want a little more detail on how a receptacle is installed, check out my channel. I've got a video on installing a single receptacle, just like we're going to be doing here. And I've also got another video on installing multiple receptacles. Go check them out after watching this video. I'm just using a piece of scrap from the last video. So there we go, we've got a real quick outlet installed. I just used some scrap wire I had laying around, so it's already stripped out. But let's go ahead and look at how it's gonna be wired in the sub panel, because there is a slight difference from the main panel. So because I grabbed scrap 14 gauge wire and I have it on a 15 amp receptacle, we're gonna use a 15 amp breaker. Remember, we just shut this panel off at the main circuit breaker panel, so everything in here is dead. So we can go ahead and install this breaker. just snaps in like so. Now here's where things get a little different than the main panel. Now I know I've said this a few times, but it is really important. The grounds and the neutrals have to remain separate in the sub panel. They cannot share the neutral bar, okay? So our ground going to the receptacle is gonna come up and land on the ground bar. Our neutral is gonna come up and land on the neutral bar. It's good practice to land your neutrals near your circuit breaker if you can. There would be nothing wrong with installing this neutral down here, but if our circuit breaker is way up here, it might get confusing what neutral belongs with that circuit breaker. If we bring this neutral up here, we're gonna land it right here, and our hot is gonna land on the circuit breaker. So let's get this landed. I'm gonna start with the ground wire, and then our neutral, looks like right about there. And finally the hot lands directly on our breaker. And that's how we run a branch circuit off of a sub panel. The only real difference is grounds are separate from the neutral. In the main panel, you can share them. In the sub panel, they are separate. So let's get the dead front on this, fire this panel up, check that outlet, and wrap up this video. So this is a brand new panel, and it came with a brand new panel cover. Notice there is a spot here for a main circuit breaker. Again, that's because you can buy a kit to actually install a main circuit breaker. Also notice it comes with 2 breaker spots already knocked out. I've only got 1 installed, so I also got some blanks we can put in that 1 spot. Another thing I wanna mention is, remember at the beginning of the video where I showed to measure that 1/2-inch distance there? A lot of newer panels actually come with a spring-loaded dead front piece here on the cover. It's actually kind of a nice little feature. It will actually make up for some of that distance if there is a slight discrepancy between how deep the panel is in the wall and how much space there is to make up between that. There is a little bit of leeway there because of this spring-loaded cover. So we can pop this on, and this is a flush mount cover. So this cover is actually specifically for installing inside of a wall. If you were installing this panel surface mount on like a concrete wall or on sheetrock rather than in sheetrock, you would need a different cover. Otherwise, there's these little sharp edges that hang over the edge. You want a cover that actually sits flush with the panel itself. And we'll install one of these breaker blanks to cover up this opening right here so we can fire this panel up. These are specific to a particular type of panel. So if you do go down to a hardware store to buy some of these breaker blanks, make sure you get breaker blanks for the type of panel you have. If you're not quite sure of what type of circuit breaker panel you have, take a picture of the breakers and bring them with you to the hardware store, and hopefully somebody there will be able to help you. Or for extra bonus points, take a picture of this sticker on the breaker panel cover. It actually gives the model number of the panel. And using the first couple letters of that model number, you can very quickly figure out exactly what type of breaker blanks you need. The HOM in this case stands for Homeline Series, whereas if we go over here to the main electrical panel, and we take a look at the cover on the main electrical panel, notice how it says QOC. This is a QO style panel. So these are QO breakers, and in our sub panel, these are Homeline breakers. So with that, everything is buttoned up. We should be safe to fire everything up. So let's go ahead and turn on the sub panel. So the sub panel is now energized. And we can plug our outlet tester into our outlet and flip our circuit on, and we get 2 orange lights, which with this tester means the receptacle is wired correctly. We've just installed a sub panel and a branch circuit off of that sub panel to demonstrate kind of the difference between a main panel and a sub panel. Remember, this distance could be pretty much anything you need it to be. This panel could have been sitting right next to this panel, maybe because we ran out of room in this panel. Or this panel could be on the other side of a building because it's more economical to run one larger wire than it is multiple smaller ones. There's one last question I want to answer real quick, and that would be, what if this sub panel were outside in a different building? What if this were feeding a detached garage? What if this were feeding a workshop or a garden shed or something like that? The only major difference is at that building you would have to install ground rods, and those ground rods would have to run to the ground bar in the sub panel, not the neutral bar. In the main panel, The ground rod goes to the neutral bar. I know that's confusing. We'll talk about that in a grounding video. But the ground rod in a main panel goes to the neutral bar. The ground rod for a sub panel in a shed goes to the ground bar, and then everything else stays separate. So you have a separate neutral bar, you have your two hots landing on line 1 and line 2, and the only real difference is you'd have a ground rod also landing on the ground bar in your sub panel. If you made it this far in the video, consider liking, leaving a comment, and a subscription if I've earned it. There is a link to Patreon in the description if you would like to support the channel further. Thanks for watching. We'll see you guys on the next one. Bye.